Okay, if you'd be so kind, raise your hand if you can hear me. All right, nice. Not sure. I think some people might be struggling with their technology because we're missing a couple. Let's give it a minute. Hope everybody is doing well. I'm gonna mute y'all. How you doing, Ian?
I'm good. How are you?
I'm doing well. Noah, how are you doing?
Oh, I'm good. I don't know if you heard me the first
I
time.
can hear you now. I'm unmuting
All
you.
right.
I'm muting you back up. I mute you just so that way dog runs through or something else. Or Ryan, how you doing?
I'm good.
Good. All right, guys. We'll give everybody another minute or two, and then we'll get started here. What is going on here? Oh no! No. Get that started here. All right. Well, we're going to start because we're here and no one else is, and hopefully they'll start joining us in a moment. All right. I hope everyone is doing fine. Now, what we're going to do is I'm going to do a quick review where things are and how where we're standing on stuff in terms of Charlotte Medi. Charlotte Medi is an organization we formed to get those face shields to everybody. As of today, let's see if I'll search it right here. Charlotte. There you go. See, it's updated. That says 908 shields. We actually have another 20. We delivered 23. We're actually more than 3,000 shields now. In fact, I told Joe. All right, and I'll use Slack. So I'm going to use Slack right now. We're going to show back that they are at the hospitals. All right. All right, so we'll come back to that in a moment. Okay, I may go ahead and edit that later today so we don't flip out his email on everybody in the world on Slack, but that's what, nice, jumped over there. Let's go back over here. So let's go through this real quick, shall we? Quick review. I'm gonna go, let's do this. Let's start from the beginning. Bear with me 1 second. Sorry about this. All right, hopefully you're up here seeing this. Well, that didn't. What the heck? That's annoying. Mr. Dubik didn't click on the right square there. All right. So here we go. All right, folks. So let's check where we are on our. The outbreak is still pretty much here, though it's now starting to show up throughout the rest of the world, which is pretty much guaranteed. That's the nature of a virus. It's really hard not to spread. Let's see what we are today. How many total cases? Worldwide, now we're getting at 9/10 of a million. We're at 900. That's annoying. 900 million. 200 million. The United States now leads the world significantly as the biggest country that has it, with over 200 million. China was at, to give you an idea, China got to 81,000. Italy was 110. So there we are with that, okay? When about 10% of deaths occurring in the United States that we know of. These numbers on deaths and recovered is going to be very nebulous. We don't really know all over, all right? And that's out of a lot of people, folks, okay? It's out of a lot of folks. All right, now, I'm trying to, okay. Then we're going to go to this. I think we're going to see this spiking up more. There we are. Okay, I agree to that. This is where we kind of knew it was going to head to, and now it is here in a big way. They're all their paywall stuff, pay stuff there. All right, here's the United States. China's curve flattened. Italy's curve's flattening some. It's not going straight up anymore. But the one that's just off the charts right now is us. And we're at over 188,000 cases. So it is, we need to get that to flatten. All right, Ryan's got a question. Yeah, Ryan, what's up?
Oh, sorry, I didn't mean to accidentally raise my hand.
That's okay. With just a few of us in here, that's the nice thing about small classes. We get to all the interaction you want. Okay, so that's where we were with that. And it is what it is. All right. We talked about there's shortage of medical professional PPE. That's what you hear about. And we talked about that engineering design process being really important to this. So, as we thought, you know, time to make it, materials, equipment to prototyping, cost. It's what you're always, and a lot of these things are honestly, are every time you do an engineering problem. It does matter what the material is. It does matter what equipment you're using. All those things, they all true. What are the medical staff saying? That's one thing. What others do in research when you do things. And that's a mask we decided not to actually use. So now we're using the face shield. And like we just said when we started over, we did over, I think we're going to be over 3,000 face shields today, which is kind of amazing. All right. As we got, when you do the engineering method, come up with your idea, but then test it, iterate, make it better. I can't stress it enough. As you go on to be engineers and technical people, see, there's R1. It was too small. R2. We don't even make the RC1s anymore. We make only RC2s. And there's an RC3 version, but we're not going to really worry about that one right now because at this point, we've got something that's working and we're going with it. All right. And then, you know, you get feedback. You're going to have failures. That's all good. Also, you want labeling. So I'll give you an idea. See how the clear strap only goes to the headband here? Don't worry about the colors. You can tell we had just different people printing it. Up here it gets much bigger. All right. And there we go. Some nurses. All right. Did fails. So they're working as intended. We found it all out. And it felt good. As we'd start to get some back, if they broke, we wanted pictures, why they broke, what do we needed to do. Don't take it personal. We're just trying to make it better. Right now, I'm saying, you know, don't, so just kind of keep, everybody should always keep that in mind. And we started our Facebook page, which, by the way, what's that up to these days? We'll look that up. All right, GoFundMe. Oh, God, GoFundMe, face shield, faceplate Charlotte. You think I've been looking at it enough now? I'll go find that. There we go. All right. We're at $92,000. Not too shabby. And what that allowed us, that's not what I wanted. I don't know why they did that. But it was at $92,000. And what that does, and I would highly recommend doing that down the road. If you're ever in a project like something like this, as you're older, it gave us money while other people were busy having to raise the money, convincing people it was important they got their money. We were able to get going, which is indeed very fortunate. Okay? All right. And that also shows you this became Medi, Charlotte Medi. It became more than the people I'm involved with, much bigger than me, much bigger than the other people involved. They it's now hundreds of people involved, probably nearly 100 people involved now. All right. I know we have 50 families or so it's got to be that. All right. So with that in mind, Slack and GitHub. I want you to see Slack now. I'm going to bring up a version of Slack. Hopefully I can get out of that. All right. I'm going to go over here. Switch to, young engineers of today. All right. This is what I want you to see. And I'm going to ask your folks. I've been very impressed with this. So what Slack does, if you're ever in a big group, you got to organize it. Maybe you're going to do some kind of school, raising money for your basketball team. Hey, Carson, glad you're with us, buddy. This is what Slack does. And we can keep adding channels. So let's learn about Slack. I got a column there, channel. Create a channel. So channel could be making contacts, contacting folks. Contact. Well, that might even be on there, but let's see. Let's say contact. Okay, create. Now, when I'm talking to my group, everybody will be able to see that column. This is a really interesting way, and I will write, it's a very good way then to do your emails back and forth. You won't get 1,000 of them. So when someone says Slack, suggest this also to your parents maybe, if they're interested. I make no money. I don't know who made Slack. I think Slack got started for another company that actually went out of business. But the number of Slack messages and stuff, my account's free. I'm not trying to sell Slack. But I do think one of the things I'm taking away from what I'm learning in this project is that was really useful, because until I started using this, I got an email chain 20 minutes long. It's like a text chain. You get a really long text chain, you don't know who said what, practically. You can't go back, can't find the text. This does this for you. Does that make sense? Any questions about Slack? Again, you set it up by your team. You can have people in yours. I think mine's got my wife and I. This is a make-believe one I did for you guys. There's some different apps in here. I didn't even Google Drive, Zoom. You can put it all in there. You can upload files and store them in there. Contact faceplates. So maybe if we're all in this class and we want to put anything about the faceplates, we can put it general. We're about to do another one would be a create a channel. I'm going to make a channel called Pete, not programming. Oh my goodness gracious. There's a visual programming language processing that we're going to be doing. All right, so we create that. Then anybody posts that's in their group has that. You can add all the people, you can add everybody into it. Whenever they were referring about processing, we post them there. So I would just highly, highly recommend this. I'm sharing this with all my students. So down the road, you certainly will go in the workforce and or be involved if you're a tech person and it's software. You're definitely, and you're going to see that. The other one you're going to see is GitHub. We'll come to that down the road. All right. So now, having said that, we'll get into something that's actually going to look pretty cool. So that was a quick 3-minute summary of what we're doing. Okay? Now, see, there's a 3D printer, and that's the fuel mold injection. And I said we'd talk about it. So one 3D printer will print 4 shields in 8 hours. Injection molding prints 4 shields in 1 minute. So watch this. Watch this. This is only a 3-second video. I'm going to make my volume loud so you can hear it. And then remind me to turn it down because it's going to get really loud. You're going to hear it in a moment. Let me go ahead and turn this way up. Watch this. See that? They're injecting out. Those are all bottle caps being made every 3 seconds. All right, they're pouring out here at the bottom. So every 3 seconds, see them all pouring through. Then they're going up this ramp here. That's them all coming out the side there. They're coming out so fast. Look at that, how clear they are. Just fill up this drum. So that gives you a sense that when you really want to make something fast that's plastic, mold injection is about the only way to go. Little, which I think is kind of amazing. Any question on that machine? This works a lot better, guys, if you'll talk. If you raise your hand, or if there's something you want to ask or say or point out about what you like about it, okay? All right. Now, again, next week, like I said, we're going to start processing, and then we're going to be building some planes to get you outside some, too, down the road. But right now, let's look at this. All right, so now, and I'm going to have you do a little activity today. I want you to do something for me. So now, see this hopper? You got raw material. You pour in basically pellets. You'll see this in a minute what they look like. It takes this barrel, turns around, the pellets go in, there's plenty of room as they're being heated with these right bands right here. So it gets liquefied. From there, it's pushed into here, and that's the mold. So, and this is called the clamping area, but just think here of the injection. Here's where the mold is, what you're trying to make in the mold cavity, and here's the clamping, okay? Now, I don't expect you to understand that first time through. Let me show you something here. This will get you a little sense of it. hope everybody saw that. It's awesome. You can see how fast things made. All right, so you can crank out everything in injection molding. So the next part of this is I'm going to go a little bit of dive on injection molding. Because I want you guys to see it. This chair is made out of injection molding. Anything out of pure plastic. Model airplane, injection molding. These little pellets are where we're going to use it. This is based on the lecture given by Bill Hammack, University of Illinois. I want to give guys credit where I'm getting content from. Really an amazing guy, and if you got engineering, he does a really super job of this. So, we're going to go through the parts of this. So, on the right, this is the injection unit. And we're going to get into labeling each of that. Again, your mold and your clamp. These are the pellets. We have big buckets of this stuff that we go in there. What's also great about these pellets is you can take that chair that's injected molded and you can recycle it and they can remake it pellets if we used it. So it's a question not of can we do it, it's should we choose to do it. And if we did things in our economy to encourage us to recycle and not just end up in the waste in the ocean. So here's the hopper. We pour the plastic pellets in. It starts to fill this up. As it's moving across in the screw, we're able to move the molten plastic down there. It becomes molten. We press that into our mold. So this is the cavity, they say. So the mold shove in there. This is where we're going to make, right here, that red line. This is injecting into it. It fills it up. Notice there'll be a little piece left over when it fills up, when it goes away. There's the mold right there. All right. Folks. So it pulls the mold there. Now look at these white rods right up here and here. All right. This kicks those molds out with that white piston. And then now that's your printed part. This part you're going to rip off. There's your printed part. Surely somebody has a question or a statement about this now. All right. That way, step up, Ian. Ian, all right. Well, I'll go with Ian. For some reason, you're muted on your end, so I can't. I got you. All right, there we go. Now I can do it. Let me go Ian first, and then we'll go to Ryan. What do you think, Ian?
How is the mold made for this machine? Are they custom made by
Great question. The mold is actually the really expensive part of this, and we're going to get to mold making in just a little bit. Once we get this process down, I'll show you. But what they do is just like honestly, that you know how we have that CNC machine with the wood? We use a CNC machine to take it out. A metal mold, it can take a week or more to make. They tend to be very expensive. $30,000 for mold is not. I think it's $9,000 a chamber. So you're going to get into real money when you build a mold. But then you have the capability to make 10,000. You can use the mold 10,000 times. So you're able to spread that cost out over it. And a high-end one could even last longer. So great question. I'm going to show you a video on how that happens in a little bit. All right. I'll put that down. Ryan, do you have a question? Ryan, you got a question?
I basically had the same question of him as him. Good. That's all.
Okay, cool. So we'll get to that one in a second. All right, or just a minute, not 1 second. It'd be kind of a short webinar if we did that 1 second. All right, so then, now let's talk about the technology of this. All right. So when they first started doing this, the problem was the outside would be nice and hot and be great, but the middle side would stay too cool. So the plastic wouldn't heat very well. And once you got the inside so hot, the outside of the plastic would be not so good. It would be burned and ruined. So they put in a screw, and the nice thing about that screw, let's go back in here. This screw, basically, and if you look up at the picture, what that does is the molten plastic stays on the outside. The screw fills most of this up. And therefore, just the outside of this gets hot, certainly by the time you get here. All right? The next thing it does is these flights allow you to send your plastic. It mixes it around. It allows it to spread the heat, shearing it, mixing it all up. And you can see it right now. So as the plastic goes in there, it's all getting mixed up, aggregated, shook up more, getting the plastic warm. Then the third thing it does is see how the molten, as the plastic goes in, this area gets up higher and higher. And what that does is the plastic's actually grinding inside this tube, so it's really going to melt now. So that went a long way to get consistency. And here you are. So here's the plastic going forward, getting blobbed out, melted. Then what happens is the plastic about to be inserted goes through these flutes right here, and this ring, as this comes up, this check ring up on top, and there's a thrust ring. So think before these meet, the plastic can get in here. See, there's the thrust ring, there's the check rings. But once you get to here, thrust ring hits the check ring, the plastic can't come out, the plastic can only go forward. These are injector pins right here. That's what pushes us out when we go through it. So here's what I really want you to do today. When you get a chance, I want you to look around in your house. And if you got plastic silverware, you're going to see these little marks, these little injection marks, okay? They're called injection pin witness parts. Injection pin witness parts. And if you start to see things in plastic, you start looking for them. You can see what that was an example of where, let me go back here. These pins pushed out that part that formed this plastic fork, it looks like. So let me show you some more examples. So on this big chair, which I find amazing to me, was done in an injection mold. But see these marks right here? 1, 2, 3, 4, 5, 6. Right there. Those are all the pins that shove this out of the mold when they make this chair. And I'll even highlight them for you. Oops, bear with me. There it is right here. See, those are all the places, all the pins push that big plastic chair out. So believe it or not, that plastic chair comes out. All right? Now, down here on the left is a date. This will tell you the date, time, when they made something. This also tells you it's recyclable. So that's what they put that information is they stamp all these chairs out. Just like with the face plates, where we wanted to know, every once in a while I'll have a failure on face plates, and I really wish I could tell. As we've gotten bigger, we're not tracking it as much on per numbers, and not everybody can label it just by the nature of that. And it's really good to have it. We've done it in the past. You can't do it as much as you would like. All right? All right. Ryan, did you have a question? Oh, my hand was up there. I thought maybe for a second. All right. So let's go on to the next part. When you make the part, you know how it's injected here? It's injected out. This is called the sprue when we get rid of that. I've got the name the sprue. Who knows? There's your molded part. This is the part that was molded in there. The sprue can then control runners that can go to all these spoons. So the injection mold, think about the injections coming this way and then spread out. And you see that little square there? You'll have like a little header right there. And you can find that on, pardon me, on your mark. So how many of you guys have built a model airplane, plastic model airplane, or car, or something that you had to glue all the parts together? All right, Ian has. My goodness gracious, it's one of life's true pleasures to make those things. Well, when you pull them apart next time, This is remnants of the mold injection. I always want to say cars had fuel injection. And that's what that's from. So, I just wanted you to see that. All right. Okay, now. Now, when you do a mold like this, the mold is never perfectly aligned. It's impossible for it to be absolutely perfectly aligned. And so you get what's called a parting line. A parting line. And you'll see that in things that are injected molded. So there's a parting line right here in this piece of plastic, you know? So if you look around, you can find these marks. And in fact, that's what I'm going to ask you to do after class today, is just walk around, see if you can find some plastic. It's everywhere in your life. And you'll find parting lines and the injection pin witness parts. These are called date wheels. Not the time, it was the date. I guess I said time a minute ago, but it's date. All right, now. So remember, when you go to inject this in, this is the remnants of this. So look, let's go back up here a second. Makes a little more sense here in one moment. Let's go back through. Come on. I'm doing. I'm going to go right to the beginning of this. All right. So I'm standing up there. Transition to volt metering that not a turbo. All right. Going in your mold. And it's that sprues right there. That's the remaining part that's going to get snapped off. Rolls it. See, when the mold comes out, that little piece of junk's going to be left over. They snap it off. What's interesting is they immediately take it at the mold injection place. They take that sprue and they throw it back in there and they reuse it. They don't waste it. All right. I'll just get back here so it makes a little more sense to everybody. All right, one thing was they pull that mold out. If it was totally square, you'd create a vacuum and there'd be a lot of friction all the way along this and it'd be hard to eject that mold. Remember, we have that part right here where you go to kick this off, right? See how we want to kick it out? We don't want rectangles. We want this angle. So when we kick it out, there's only a little bit of friction at the top. There's less friction because if you imagine as that went farther out, there'd be more and more space. Plus the air can get in there and there's no vacuum. Little subtle thing, but that made a big difference in designing these things. Now, you asked, how do we make the mold? Well, I'm going to go right here and do it. So, this is a pretty cool vid. It's about 3 minutes long. I'm going to make it obnoxiously loud so you can hear it. All right? So here we go. Well, let me go back.
If you take a close look at the products around you, you'll notice that many are made of parts that have been assembled together. One way factories make product parts is by melting materials such as metal, rubber, or plastic, then pouring or injecting them into molds. To make a plastic part for a product, the manufacturer has to first commission a mold-making company to design and produce a plastic injection mold. The mold begins as bars of chromium steel, a high-durability metal that can withstand repeated high-pressure injection of plastic. Workers assemble several bars into a block called a mold base. They mount this base on a milling machine, which shaves the bars to the right dimension. This step is critical, enabling them to later machine the base into a mold that's faithful to the technical design, right down to the 100th of a millimeter. A mold usually consists of two halves, each of which is comprised of several components. The factory drills strategically positioned holes in the bases for the guide pins and bushings that hold the components together when the plastic's injected. A grinder now goes to work smoothing and leveling all surfaces. This prepares the base for the high-precision machining operations that will transform it into a mold component. A computer-guided tooling machine called the CNC.
That's a CNC, but that's just a version of a CNC. We have a shot bot on this. I would like to get a mold injection for the lab. I really do want one. I just got to figure out how we can use it.
Slowly machines the base, wearing away the steel particle by particle to create the mold component's shape. This one, part of a mold for the plastic rim around a snowmobile's front headlight, takes 20 hours to complete. From here, most mold components go on to a second tooling machine, especially if they have some fine detailing that this CNC machine isn't capable of carving. The second machine is outfitted with a copper electrode in the shape of the plastic part, in this case a snowmobile oil gauge. After polishing the electrode to ensure flawless casting, they use a sophisticated measuring device to verify the dimensions. The electrode goes face down on the second tooling machine called the EDM. Directly underneath is the mold half that's already been partially formed on the first machine. A strong electric current runs through the electrode and penetrates the mold, forming a cavity in the shape of the electrode. After tooling, they drill coolant lines. This is for the cooling fluid they'll use to accelerate the hardening of the molten plastic. Some plastic product parts, like that snowmobile oil gauge we saw earlier, have lettering on them. The factory engraves the letters in reverse inside the mold cavity. After the plastic's injected, the writing comes out frontward and raised. The surface of the mold cavity is pretty rough from all that tooling, so they polish it smooth to ensure a proper casting. Here's what the two halves of a finished mold look
You can imagine they've spent now thousands of dollars to get to that cleanliness.
like. The pins and bushings fit together to close the mold before injecting the hot liquid plastic. Once the plastic cools and hardens, it's just a matter of extracting the molded plastic part. Here's a different molding method. A two-step process they're using to make these buttons that go on the steering handle of a jet ski. First, they mold a structural base out of hard white plastic. Then they put the base into a second mold and inject a rubber-like gray plastic. This softer plastic covers everything but the raised lettering, giving the button a softer feel. Factories also make molds for aluminum injection and rubber injection, among other materials. They build those molds from different types of metal, but using the same techniques.
All right. So I wanted you to see that. Any questions about the molding on that? Okay, if not, here's the next thing I want you to see. All right, so here is the mold injected face plates that we're now making. Okay, so this is what we can do these. This is where we can do the mold injected stuff, the white stuff down here. We can do, like I say, 4 of those a minute. Here, whoops. Here is the mold. That's the actual mold that was being made to use for those face plates. Here's the mold injection machine. Here's where you pour in the material, you melt it, you heat it up, and we put it into the mold itself. This is down in Gastonia. That's actually right there. That's the white powder. They put it in 5-gallon barrels of it. All right. Now this is the side of the mold. Let me show you up here. So I don't know how I did that. There's the handful of the stuff, of the plastic pebbles. I'm calling them pebbles. There's a mold on this side of this and a mold on that side. So the right mold, this is the right mold. This is where the injection's coming through. And there's the left mold, and these are where the injection pins come out. So if you look at it, right mold's coming through, injection pins. And there's material coming out pretty rapidly. So let's watch this. So that's how the mold starts working. Now I want to show you the money shot. Let's go to the next one. Watch this one. This is the money shot. Check it out. Here comes the pin through here. And that's what kicks out the mold. Cleans up, does it again. Try it again. So it's filled it in. This thing's separating out. It's coming out. It was filled with injection. This we're going to get rid of. That's true. There's the pin. Pushes it out. Falls down. And this just repeats this over and over again. One more time. So, inject it. Pins come in. Press it out. Drops it in. And folks, you now know, well, there we go. So they just start piling up at the bottom of that. So you now know more about mold injection than I would be willing to say 90% of the 95% of the adults out there do. All right, any questions about all of this? All right, Noah's got a question. Yes, Noah.
My question was, is it cheaper to injection mold than 3D printing?
Yes, very quickly. Because that 3D printer, let's talk about it. So you got a 3D printer. Well, it depends which stage you're in. Let me answer it better that way. If you're at the beginning stage where you're prototyping, you're iterating, like try out an idea, test it, try it out an idea, test it. 3D print those parts. You're only making one of those. It does not work. But once you're getting up to volume, where I want, for example, we're shooting today, we sent out 2,500 parts or something. It would take a lot of 3D printers to do it. And 3D printers, it wears them out almost, is the way I would describe it, right? They're just not designed to run continuously, not the kind of 3D printer you have in your house. So, so in the beginning, use 3D printers to prototype, get a working model, and you continue. We're still using 3D printed. We're still producing 3D printed face masks. We basically have a printer farm going, and so now we got that. So then once you're happy with that, then you go to injection, and then it's very cheap. All right. I think I forget.
All right.
Okay. All right, anybody else with a question? All right, what I want you to do, and then if you can take a picture, and this class is meant to be fun, not to stress you out. Go back tonight and see if you can find a piece of plastic in your house and see if you can find these marks. They're going to be real subtle. They're not obvious, or people wouldn't buy it to think it was broken or something. But see if you can find these marks. So you can find the pin, injection pin witness, they call parts. Also parting lines, where you can see where the plastic, that's a little bit easier to find sometimes. And then obviously if you have a model kit, you'll find runners in them all over the place. All right, everybody? Well, with that in mind, did anybody have any questions? Okay, this was the last, so we'll meet again next Monday. We'll have you actively doing things come Monday. This won't be pure lecture like I'm doing, okay? I do want you to know that. All right, so we're gonna probably start off with some programming with you all. And then, since you're middle school, I'm trying to decide what language we're going to use with you. Let me ask you this. How many of you programmed in Python? All right, great. How many of you, all right, put your hands down. Let me see the next one. How many of you programmed in Scratch? All right, put your hands down. How many have never programmed at all? Okay, so everybody, at least everybody's programmed. All right, that's good to know. I have something in mind we're going to go ahead and do and get rolling on this. Okay? And I'll talk to you all later. All right, everybody? All right. There's no questions. Thank you very much, everybody. I'm going to stop recording this, and you have yourselves a great day. I've got another webinar with the high school kids in about 6 minutes.